it's working. 2018, number 4. When you take a look at the questions, they're always the same questions, but different context. That's right. Can you do you remember this one? Number 4, take a look. They always said the function is twice differentiable, which means the graph of this function will be a smooth line, where ht measured in meters and t measured in years. That's not rate, just like our original function. Okay, h is given by there. They're already asking you these questions. H prime 6, that's the rate. Derivative is always rate. When t equals 6. But there is no errors about 6. Okay, we take rate estimation. The rule to estimate this number, we use these two numbers, 5, 7, and its y value 11 and 6. You have a 5 over here, so I'm gonna make a little plot over here. Okay. If this is 2, that is 1.5. This is 3, it is 2. And this is a 5, that is 6. This is 11, that is 7. This is a 15, and this is, oh no, this is a 10, I'm sorry. 7 is 11, 5 is 6, 7 is 11. This is 7, this is 11, and this is a 10, that is a 50. So we're going to find h prime 6. H prime 6 is derivatives between over here, right? So we're going to use this sequence, our definitions. The slope of this one is actually equals to what? Not is actually equals, estimate, okay? The slope of, I'm going to say A and B, the line A and B. That is h prime 6. This is the rate, okay? All right. Now let's find the slope of this line AB, okay? We know that f of 7, right? So h when x equals 7 minus when h equals to 5, that is y2 minus y1. We already got the number there, 11 minus 6. And x2 minus x1. 7 minus 5, okay? That's the time, okay? So t equals 7 and t equals 5. This is 2. This is a 5 over 2, or you can use 2.5. Okay, this is what the rate, okay? The rate is what, meter per year, okay? Meter per year. That is the estimation of this number, okay? H prime 6. Okay, interpret the meaning of H prime 6. Okay, what is the meaning of this one? How can you say? This is the rate, okay? This is the rate when x is what? 6, right? After t is measured in years, so at 6 years, okay? At time t equals 6 years, so the rate is the rate of changing the height. Okay, of a tree, right? It's okay? Changing of a tree, that is the rate of change, okay? You can say. when at time t equals 7 years. You can explain this way. The number A is okay. We change by h prime 6 over here. The slope of this one, we take this slope as h prime 6 between these two numbers. Okay, so h over 7 right after 6, 7. Before 6 we have only 5. Okay, so y2 minus y1 over x2 minus x1. Okay, that's the slope approximate h prime 6, because 6 is between 5 and 7. Okay, it is understandable, number A.
Yeah.
Okay, next number, questions B. Explain why there must be at least one time t. Okay, at least one times t between 2 and 10. Between 2 and 10 over here. Maybe we graph over here, okay? 2 and 10. H prime t is 2. H prime some value of t is 2. The slope, this one is what slope at time t equals some time t. Slope is 2. This represent what? Mean value theorem, isn't it? There are at least what? 1c, which is equals to this one, right? That is mean value theorem. Is okay? Mean value theorem is what is there. You can use this one. So the h over b minus h over a over b minus a, that is the slope of between 2 points. Because only this point is given, right? Only 5 points given. Using this point, we're gonna find out, okay, slope of this one equals 2. This is equals to h prime t. That is the time t. T must be what? Between a and b, right? That is mean value theorem. So we're gonna find the mean value, two intervals which has what their slope is 2, because they are equals 2, right? Which two sides is 2? First over here. 2 minus 1.5, check it out, okay? 2 minus 1.5, y2 minus y1, and 3 minus 2, x2 minus x1. This one is 0.5 over 1. That is 0.5, right? That is not equals to. We cannot take this interval, okay? Now check out the next intervals. 3 and 5. y2 minus y1, 6 minus 2 over 3, and x2 minus x1, 5 minus 3. Check it out, this one. 4 over 2, that is equals to. Yeah, that is equals to. We take right these intervals, 3 and 5. When you take a 3 and 5, these intervals, for example, one more time over here. We have slope of this we already got over here, right? Slope is 2, right? But this is differentiable over here, smooth line. Okay. This is a continuous. They said it is twice differentiable means or continuous, right? It implies continuous. There is just some value which has what? Same slope. Some value we see there, right? Same slope. They are parallel. That is mean by your theorem. It is okay? Now we got the interval already, 3 and 5. That's right? So what is that? It is differentiable. The reason is what? ht is differentiable. Okay. And on this equals greater than 3 and 5, between only these two, right? These two, that resist C at least C, which has what? You already got over here, okay? HB, so H5, I'm going to write down H5 minus H3 over 5 minus 3 equals 2, right? Such that. And write down this way, okay? This is your mean value serum definition, okay? Is it okay? I'm going to summarize one more times. If we have A and B on this interval, they are differentiable. Okay, on this interval, HT is differentiable. First one, HT is differentiable. First one. The second one is then f of b, slope of these two lines, okay? Slope of these 2 points. HB minus H of A over B minus A. Okay, if differentiable, I'm going to write down directly, okay? If HT is differentiable, there exists a C, at least a C, okay, such that this one is equals what? F prime C over here, right? But C must be between A and B. That is mean value theorem. You have to memorize this one, okay? Are you okay with this mean value theorem? This is a differentiable, continuous. We have a slope of these two lines. This one is A, this is a B. What's the slope of this one? Height is f over b, right? I'm going to do HB on these questions. HB, this is the HA. Slope of this is just, we said line secant. Slope of secant is h of b minus h of a and b minus a. That's the slope. But you can see that this smooth line, there just was some value of c there, right? Which is what? Same slope, always, because that's a differentiable. There is just a C, but this should be between A and B, right? Okay? So, first one is, what is that? HT, if HT is differentiable, if HT is differentiable. Then you can make a conclusion. Then, there is just this value of C between A and B. At least C, right? If you graph this one, there are 2 points over here. One C over here, another C over here, right? So there are just at least one C such that satisfy this, okay? Which one? This equals HB minus H over A over B minus. That's the slope, has the same slope as some value of C there. Derivative. This one is what? Derivative, right? Tangent, slope of tangent. That is the mean value theorem. Maybe you better memorize this one, okay? All right, number C, use trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of a tree over time interval 2 and 10. What is the average height? Number C, that's when you find average height. What is the definition of average height? Sum of all this height, 2 and 10, h over t dt. After that, you can divide by the bottom, right? 10 minus 2 is 1 over 8. That's the average height. But this one, we cannot find the exact numbers because the equation is not given. ht is not given by the equations, only given by the table. That's why we have to use approximate Riemann sum, okay? But this time the trapezoidal. Okay, now let's find approximate area of this one, okay? This is the real, but approximate this one. I'm gonna write them one more times. 1.5, this is the 1, 2, okay, this is the 1. I'm gonna do this 1.5, that is a 2. 2 over here, very close, that is a 3. 5, 1, 2, 3, 4, 5 over here. That is 6. 7, 6, 7 over here, that is 11. 8, 9, 10, that is the height is 15. Okay? So we have a 4 interval, right? 1, 2, 3, and 4. Make trapezoid. This is trapezoid, another trapezoid, trapezoid, trapezoid. There is 4 different size trapezoid. So we take all this area, okay, for their approximation of this value, okay, integral. So bottom is 2 over here, upper base is 2, this is 3, right? So 2 plus this is the first one. First trapezoid is what? 2 plus 3 times the height. This is the height, 0.5, and divided by 2. Okay. 5 times 0.5 is 2.5, and divided by 2 is 1.25. That's the first area of a trapezoid. Second one over here. This is 3 now, this is 6. So base 1 plus base 2. 3 plus 6. And times, this is the height is 3. Times 3 and divided by 2. 3 plus 6 is 9. 9 times 3, 27. Over 2 is 13.5. Third one. This is 6, this is 11, right? Upper base 6, the bottom base 11, and the height is 2 over here. And divided by 2. This is cancelled out, will be 17. The last one over here. This is 11, this is 15. So base 1 plus base 2, 15 times the height is still 3 and divide by 2. Now take that is 26 and divided by 2 is 13 times 3 is 39. Okay? So we're going to add all this area, right? That is your approximate distance integral. Okay. Okay, we'll rearrange this. 13.5, 17, 39. This is 5. Okay, that is 7. 2 plus 5 is 7. This is 10. Another 10 equals how much? This is 4, 11, 20, right? Just 1 minute. I just misunderstood this one. When 2 is that is 1.5. How about this one? This is 1.y. This is yx, okay? Yeah, terrible. It's empty. 2, 3, 5, 6, 7. 2, 3, 5. This is okay, but this is wrong. The next is 2, 1, 2. Let me see. 2, 3, 5, 7, 2. This is a 3, this is 2, okay? So when t is 2, 1.5, height is 1.5. When t is 3, height is 2. The next is 6, oh, that's true, okay. First one is, first 2 is wrong, right? This is 1.5, not 3, this is 2, right? So 1.5 times this is 1.5 plus 2 times 1 and divided by 2, right? So 3.5 is 1.75. This is not 1.75. Second one is 2 and 6. And divided by 2, 8 is, that is 12. Yeah, this 2 is wrong. This is 12. Okay? Alright, now let's find. 5, 7. This is 3. And 8, 12. Check. Just a moment. I'm going to check it out more times. That's correct. Let me see. 3 and 5, okay? That is the length is 2. I don't know how come this 3 over there. Check. This is 2, this is 3. The height is 2, right? This is 2. So that is 8. Sorry about that. This is 8. Now everything okay, right? 2, 3, 1. Okay, that's fine. Okay. Now this is 9. 9 plus 7 is 16, plus 9 is what? 25. 2 up here, 2 plus 3, and another 3, 65.75. Yep, that is correct. But put this number in here, right? That is approximately, you can divide it by 8. Because from here to here, length is 8. Because you gotta make right flat over here. When you divide it by 8, that it looks like one. This rectangle, right? Divided by 8, they are all same height, right? That is average, okay? So this is what? Average height. You can divide it by 8. So that is how much is for 65.75, right? But you can leave it this way too. I think that is okay, but also you can divide this one. Okay, 25 divisible by 6. Check it out. 8 is 64. 17 is what? 2. 16, 15. 1, 8, 70. 8, 64. 60. 5. Okay. Look at this one. This equals 8.21875. Okay? Meters. That's the average height. Okay, you can use this one. Okay, a little more work, right? That this is a trapezoidal approximation. Okay, Ivo, can you do that? This one? I don't think it's okay. Okay, try, okay, only A and B, okay? But trapezoid, that is not that much work. Oh, you can try up to number C there, okay? Right, anyway, we're gonna try number D again, okay? All right, the height of 3 meters can also be modeled by function g of x. Okay, they make approximate equation of it. G of x equals 100x over 1 plus x. Where x is diameter, that is a different equation. Oh, okay, different equation. That is here, this is why x is a diameter. X is the diameter of the tree. And where trees are 50 meters tall, diameter of the base is increasing at the rate. Okay, when the height is what 50 meters tall. Okay, so when g equals 50 meters tall, g equals 50 meters. Okay, the tree of base, the diameter, right? Diameter is increasing at the rate is 0.3, okay? This is diameter, so dx dt equals to 0.03 meters per year, okay? That's the given at this instant. At this moment, diameter, changing of diameter is 0.03 meters per year, okay? According to this model, what is the rate of change, the height of a tree? We're gonna find, okay, dg dt. This is the height at this times. We're gonna find dg dt with respect to time. At time when the tree is about 50 meters tall, right? At this situation. Okay, now let's find out here. So how can you find dg? This is the related ratio, okay? Related rate, gx and x over here. But we take a derivative with respect to time, okay? Okay, take a derivative. G prime is what? dg dt, right? That is dg dt equals denominator, okay? Quotient, right? 1 plus x squared. Are you okay with this? But you gotta be careful, right? X is a function of time, okay? We take derivative with respect to time, not x, okay? So first one, 100x. 100x is what is that? dx dt, right? Derivative. Okay, first one, derivative times denominator, 1 plus x. Is okay? The minus. First one, don't touch. And take the derivative of denominator, right? Denominator is x of it. That is also a dx dt, right? Okay, now let's find these numbers. dx dt is given by here, 0.03. Put this number in there, okay? So 100 times 0.03 is how much? 3, right? So 1 plus x. I'm going to move this 1 plus x. That's okay. So 100 times dx dt also 3, and we have minus x there, okay? This is 0.03 times 100 and times x. This is 3x, okay? Minus 3x over 1 plus x squared. Maybe you can a little simplify this. 3x minus 3x is this is 3 plus 3x minus, can't plus minus out, that will be 3 over 1 plus x and square, right? That's it. But that is dg dt. This is dg dt. But we still we need to get right the value of x. At these situations, When g is 50, what is the value of x? From the equation, we can find the value of x there because we need this value of x. Okay, so gx is 50. So 50 equals 100x over 1 plus x. We have to solve this one, okay? From here, we can get the value of x now. Because only the value of g is given, okay? So cross multiplication. Or 50 times 1, okay, you multiply 1 plus x both sides. 1 plus x both sides, how much? 50 times 1 plus x. I'll go to that one. That is equals to 100x. So 50 plus 50x equals 100x minus 50x both sides, 50 equals 50x. So x equals 1, right? At this times, the height of tree is 50, diameter is 1, right? Diameter is 1. Now put this number in there, okay? Now you get dg dt. dg over dt equals now how much? 3 over 1 plus 1 plus 1 is 2 squared is 4, right? Yeah, that's the answer, okay? That's what? 3 over 4 meter per year, right? The height change, okay? Every year, 3 over 4 meters change. Are you okay with this? But if you got right, try, okay? I think this question is not that much hard, okay? What is the number of questions? Number 4, okay? Yeah. So you have to try to figure out this one, okay? All right, the next number 5, you're gonna try next number 5 there, okay? The function fx is given e to the x cosine x. Find the average rate of change. That is not average value. Average rate of change was between over this. What definition of average rate of change between 0 and pi? Average, the first one is average rate, okay? Average rate of change between 2 points. Of f means what is that? On these intervals, x equals 0 to pi. Okay, on this definition, what is that? F of pi minus f of 0, that is y2 minus y1 over x2 is a pi, x1 is 0, okay? That is the average rate of change of f. Okay, we have to solve this one. Put this number pi there. F of x, this one over here, put this number x is a pi in the x, okay? E to the what? Pi cosine pi minus put the number 0, e to the 0 and cosine 0 over pi minus 0. That is the average rate of change between x and pi. Cosine pi is a negative 1, you know that. Cosine 0 is 1. This is also 1. So, negative e to the pi minus 1 times 1 is 1 over pi. Are you okay this? Or you can a little look, change it a little nice, looking nice. Minus move out is pi plus 1 over pi. But this is okay too. But you can leave it this way or this way, okay? Already they gave this question, okay? Average rate of change. Definitions. Average rate of change. Average rate of change what? The slope of secant between 2 points. We did already, okay? If this is f of a, this is f of b. So f of b minus f of a, y2 minus y1 over b minus a, right? Yeah, that is average rate of change. The slope of this line, okay? Oh, this one, remember. Okay, we this one later, okay. No, the next one will be. B is there. What's the slope of line tangent to the graph at x equals 3 pi over 2? The equation over here given. F of x equals to e to the x cosine x. To find the equation of line tangent line, we need a point and slope, right? The x coordinate is given. Okay, now let's find the point first. Okay, put this number x in the equation, you get the y, right? This is the y value, okay? So f of 3 pi over 2 to find a point. Put this number x 3 pi over 2 and cosine 3 pi over 2. Cosine 3 pi over 2 is 270 degree cosine value equals 0, right? Or 0. So the point is now when x equals 3 pi over 2, y still 0. That is the point. Now next one we need is slope, right? Slope at this tangent point, okay? So that means what? Slope of tangent line, okay? So that is derivative, isn't it? F prime 3 pi over 2, that is the slope of tangent. To find this one, we take a derivative of this one. So f prime x first. Combine this, okay? First one derivative is e to the x times cosine x. Plus, don't touch first one. Second now derivative. Derivative of cosine x is a negative sine x. That is f prime x. But we need the slope at x equals 3 pi over 2. Put this number in the x. So f prime 3 pi over 2 there. That's the slope. E to the what? 3 pi over 2. Still cosine 3 pi over 2. E to the 3 pi over 2 minus sine 3 pi over 2. Cosine 3 pi over 2 is 0. 0 times n is all the way 0. But sine 3 pi over 2 is negative 1. Negative 1 is what? This is a positive 1. So f 3 pi over 2 derivative, which is slope, will be this positive 1, just what? E to the what? 3 pi over 2, isn't it? That's the slope. Now we got the slope and point already. What's the equation of a tangent line? Oh, we don't need to find the tangent line, just the slope, right? Yeah, that's the slope. E to the what? 3 pi over 2 is the slope. Or you can find the equation of tangent, y minus 0. Slope is e to the negative of 2, and x minus x1 is 3 pi over 2, right? This is the equation of tangent. I thought they're asking you equation, but over here, just the slope, right? Yeah, just slope is what? You can find only this one. It's okay? All right, the next question is number C there. New pages. Find absolute minima. Find absolute minima. the lowest point. Okay, we're gonna find the absolute minimum. Okay, we check it out. For what value of absolute minimum? We're gonna find out its graph of the first derivative, right? Okay. Only what 0 and 2 pi because we don't know, okay? The 0 over here looks like this way. So we're gonna find these two lines, right? F's local maximum, local minimum, and compare these two values. Okay, that's why we can find, okay, the lowest number. If this number is lower over here, this is why absolute minimum. Okay, we check out only this number compare, right? Okay, now let's find the local minimum first. How can you find the local minimum? It's a derivatives. We take a derivative already over here. F prime x is here. E to the cosine x. I'm going to write down, copy this one, okay? F prime x e to the x cosine x minus e to the x sine x. Not make equal 0. Okay. Now let's find the value of x which make equal 0, okay? So e to the x is cannot be 0. E to the x is out. We got to cosine x and minus sine x equals 0. This one cannot never be a 0, but the only solution is what? This one should be 0. Cosine x must be equals to sine x. What value of x sine and cosine equal? Because what the value of x is between 0 and 2 pi. Better use the graph over here, right? Okay, this is one cycle, 2 pi. Half of this one. Another half of there are the 4 intervals. Height is 1, lower is negative 1, okay? Now take graph of this y sine x. This is the maximum is 1, minimum is negative 1, okay? The graph of sine x is start middle. The graph looks this way. The graph of cosine is this one. We start from here. Cosine is this one. So we have two intersections over here. This point and this point. Look at this. This point is a co-function, right? They are equals to pi over 4, right? 45 there in the middle. This is pi over 2. This is pi over 4. So x equals 1 value of x equals pi over 4. The other one is x equals, this also same thing, pi over 4, right? But this is pi, another pi over 4, 5 pi over 4 there. It's okay. So which point has absolute minimum? Now check it out. F prime x. This is 0. This one is pi over 4. Over here, 5 pi over 4. You can take over cosine x minus sine x. Over here, this is cosine x minus sine x. Before cosine x is higher, top that is a positive. After this, sine x is high, so sine x is big, so small over minus big, that is negative. But this time is a relative maximum, right? Increasing and decreasing. Before 5 over 4 over here, sine x is higher than this one. Sine x is bigger than cosine x, that is negative. This is negative. And right after this, we can see that cosine x is top, sine is lower, that is positive. This is what minimum value, okay? The graph looks like this way. From here, increasing, decreasing, still increasing again. So we're gonna find the minimum here, right? Compare this is minimum too. Okay, so f of 0 first. F of 0 is how much? Can you see that f of 0? E to the 0 is 1, okay? E to the 0, cosine 0, minus sine 0. E to the 1 equals 1, cosine 0 is 1, sine 0 equals 0, right? So that is equals to 1 there. The minimum, we start to 1 there, okay? But take a look at this point. This is higher than this one, lower than this. We're going to check it out. Put this number 5 pi over 4 there, okay? So e to the 5 pi over 4 cosine 5 pi over 4 minus sine 5 pi over 4. Cosine 5 pi over 4 is how much here? Cosine 5 pi over 4. This one is what? Sine pi over how much? 1 over square root 2, right? This was a negative 1 over square root 2. So this is how much? Negative 1 over square root 2. Minus sine pi over 2 is how much? Sine also what? Negative 1 over square root 2, right? This is increasing. We don't care about this one. Only we're going to check this too. We're going to put this number original function. Okay, we did wrong. Okay, we did wrong. Okay, we're going to probe it. Okay. F of 0 there. Sorry about that. F of 0 is e to the 0 cosine 0, okay? Cosine 0 is 1, e to the 1 is 1, that is 1, okay? Oh, that's the same as before. A second one is e to the what? 5 pi over 4 and cosine 5 pi over 4. But this cosine 5 pi over 4, right? Negative 1 over square root 2 times e to the what? 5 pi over 4. But this is a negative number, this is positive, this is lower, right? So this is what? Absolute minimum. Is okay? Yeah, this is absolute minimum. So that's the answer, okay? But that's can you find the absolute minimum, right? At x equals 5 pi over 4, absolute minimum. Negative 1 over square root 2 e to the what? 5 pi over 4, right? That's the answer. This is the correct answer, okay? Because we don't check right this one because this is an increase, okay, higher than this one, okay? Yeah, we don't need to check it. Only what? This one and the minimum value, okay? Local minimum. We check only these two is enough, okay? Or other one doesn't necessary, okay? Okay, okay, we try number D one more, okay? Number T again, okay? But I suggest to try these two questions only, okay? You can do that these two, right? C and D are a little hard, but C is okay too. Okay, possible. Okay, you can try A, B, C, but at least you need to solve right these two questions A and B. Okay, every question A and B is not hard. Okay, you have to focus right. Every question have right A and B. Okay, two questions. Now, last question over here. There, G is differentiable. We're gonna make a new functions create. G is over here. Differentiable function. That's what Gx is differentiable. And one of the information is given by here. When pi over 2, x is pi over 2, that is 0, right? Pass through to 0. Yeah. And G prime is shown below. Okay, over here, G prime is given by here. So we're going to find, okay, limit x close to pi over 2, f of x, and g of x. Now we're going to find the limit value of here. All we need to check, right? We can use the L'Hopital's or some other one, okay? Put this in pi over 2 in there. Check it out, first one. F over pi over 2 over g over pi over 2. Is this how it looks like? G over pi over 2 already given by 0. What is f over pi over 2? Put this number in there, right? Over here. F over what? E to the pi over 2. E to the pi over 2 and cosine pi over 2. Cosine pi over 2 is 0, right? There is 0 over 0. That means we have to apply L'Hopital's rule, right? Okay. That is exactly equal to this one. F prime x over g prime x. F prime x we already got there, okay? E to the x cosine x minus sine x there, okay? Over here. E to the x cosine x minus sine x. E to the x cosine x and minus sine x. And over g prime x. G prime is by x minus 2. Okay? Okay, take it out. Put this number pi there, numerator. E to the what? Pi over 2 is it 0 again? Cosine pi over 2 minus sine pi over 2. That is not 0 anymore, okay? Cosine pi over 2, that is 0. Sine pi over 2, that is 1. So numerator, what is there? Exactly equals to what? Negative e to the pi over 2, right? I'm gonna put this already. Over g prime pi over 2, that equals what then? Negative e to the pi over 2 over g to the g prime pi over 2. G prime pi over 2 over here. Okay. This is g prime pi over 2 over here, right? That's the height is 2. That is g prime pi over 2 is 2 there. Okay, that is the limit value, okay? This is the limit value. Okay, number 5, okay, first two is okay, I think. Okay, C and D, maybe you can try C, or if you understand the L'Hopital's rule, how to use L'Hopital's rule, okay, you can try number D too, okay? So next time, so you're gonna do number, finish this one, slope field. You know that always this type of questions will be given into questions. Okay, the test always give this one. It's almost same thing. It's very similar, right? The process to find the answer are almost the same. Okay, almost the same. Any test. So you have to focus what the pattern of the array of questions. Okay. All right. So up to here we finish this one. Next time we will finish number 6, which is slope field, After that, we go back to multiple choice again. Okay? All right. I'll post this on YouTube and send out the link. Okay? You have any questions? Can you hear me? Something wrong. Okay, I'm gonna send out the video. Okay. All right. So I stop here.